Thanks everyone for coming to the Cloud Methods Working Group, Birds of a Feather. I'd like to introduce our speakers. So we have Erdal Cosgun, who's here, who's a senior data scientist lead for the Microsoft Genomics team in Microsoft Research. And online, we also have Tyrone Lee, a senior software engineer at Harvard Medical School, and also Alex Mahmoud. They are here. They're also at Harvard Medical School as a software cloud engineer, research engineer. And they'll be talking about their work in the Cloud Methods Working Group.
Thanks, Jan, and welcome everyone. So today we are going to share the latest updates about our working group. And we have two speakers, Alex and Tyron. So they will share their works and the projects about the cloud and the cloud technologies. The first item is we deployed this group last year, 2023, early 2023. And we started with understanding the Bioconductor users' requirements and the needs for the cloud technologies. And early this year, we started to create our strategic plan. I think this is one of the earliest example of the strategic plan for the working groups. And we would like to focus on the specific missions and our vision about the cloud working group and the cloud users on the Bioconductor community. And we will share the slide deck with you, so you will have an access to our strategic plan. But we would like to focus on the three main things for the cloud users and the Bioconductor community. The first thing is the security, sustainability, and the usability. And you will see all the details on our strategic plan. But in overall, we focus on whenever the Bioconductor users using the cloud technologies, they are in the safe zone. We should think about the security features, about the cloud technologies and the Bioconductor tools. We focus on sustainability and the usability of these kind of cloud resources. And I hope you will have a chance to join our monthly meetings, because we are having a great discussions about the cloud and the cloud technologies. And our second item on our list is the GitHub Actions. Alex is working on the GitHub Actions, and he will share his works, I hope. Just give me a second. Alex?
Yep. So I just want to talk a little bit about the overlap between the core and the cloud working group in terms of GitHub Actions. So over the past year or so, there's been a few presentations about GitHub Actions, mostly from the R Workflows team, which we've been trying in the core. So this is work that it's not just me, it's me, Jen, Marcel, and other people in the core looking how we can leverage GitHub Actions first for a new BBS system that does not require us to have hosted infrastructure all the time, and possibly get closer between what we are using to build and what users can use in their own development and to test their packages. So that's something that we're exploring. We're looking at the R-Universe stack because they currently have a GitHub Action-based building stack for across platforms. So we're looking to see how we can either collaborate with them or reuse some of the open source pieces that they are using in the stack. And then the second part of it is something that we want to make available for developers to be able to test the packages a lot earlier while they're developing. So right now, there are some options already out there, like BioCDis, which offers Bioconductor-specific testing GitHub Action. and then our workflows, and use this, which offer more general GitHub Actions for testing packages. But we're thinking about how we can give like a very full workflow that we can endorse as the core, and almost guarantee, or be as close as possible to guaranteeing, that once your GitHub action runs successfully on your development repository, that it will also pass our build process. And that's kind of the overview of the overlap with GitHub Actions.
No, cool. Thank you, Alex. So if you would like to learn more about the GitHub Actions and our plans, please reach out to Alex or join our Slack group, and we are discussing the details. So the second thing is we activated the storage defender for the Bioconductor Hubs. That's one of the important part of our mission, because we talked about on our strategic plan, we talked about the security, the sustainability, and availability for all the Bioconductor users. And as you might know, the Bioconductor Hubs running on the Microsoft Azure Genomics Data Lake. It's a public repo for the public data sets. And whenever you use the Bioconductor Hubs, you are using the Azure infrastructure. And we activated the defender for the Bioconductor Hubs. It's very important because we would like to keep the Bioconductor Hubs and the files safe. Therefore, whenever users use the Bioconductor Hubs data, they are sure that the files that they downloaded is the right file, and there is no the viruses or Trojans whenever they downloaded it. And we started this task early December last year and completed around mid-January. And for now, we can process 2,000 files per minute for each storage account. This means each the Bioconductor Hubs the folders, and the maximum size that we can scan is 2 gigabyte. And on the other hand, we don't have any impact on downloading speed. Therefore, users probably don't feel any differences, but now they are using it, and the Bioconductor Hubs defended with the defender. And maximum monthly scan size limit is 5 terabyte. Probably it's going to be enough for the midterm, but we are working on increasing this limit, and we would like to keep the Bioconductor Hub datasets safe. So as I mentioned earlier, we completed our first draft of the mission of our working group and strategic plan. We started the GitHub Actions, and we completed the defender creation of the defender for Bioconductor Hubs. And as a feature, we are tracking the specific attacks, if any. We didn't have anything else until today, but we can easily track the threats to the Bioconductor storage accounts, Bioconductor Hubs storage accounts. And this is just a single topic that we would like to discuss with you, maybe in the next working group meeting on August 15. We will start this discussion because we would like to learn more from you. Maybe we can start today. What's your specific requirements for using the Bioconductor packages or Bioconductor datasets? Would you like to use the cloud-only methods, or do you have any hybrid environments or infrastructure, or you can just use your laptop or your on-premises like HPCs. So we would like to start this discussion because we would like to keep the Bioconductor community live on the cloud infrastructures and using the cloud infrastructures for their needs, like scalable analysis. Today, I saw a couple of presentations, and most of them, maybe in near future, should be scale up on the compute side. Therefore, our working group can be a leader for providing a guidance and providing the documents for the best practices on cloud. And the fourth and the last topic is the large language model tests, or the maybe early findings from Tyron. Tyron, you can share your screen. I hope you can hear us.
I can and will.
By the way, if you have any question, we will have a Q&A session at the end of the presentations. Thank you.
So this is a very short project that we conducted within the at HMS, formerly Center for Computational Biomedicine. Me, Ludwig Geisinger, and Tess Durga were able to test out a few applications of LLMs. There's a lot of buzz around this, and we wanted to see, particularly for this use case of trying to augment the Bioconductor support site. If you're not aware, we have support.bioconductor.org is a forum for asking analysis and coding questions related to Bioconductor packages right there. There we can get answers from experts in the field. Unfortunately, if you notice on this screen right there, this has been updated about 7 years ago. It's where encourage a lot of people to use it, but how do we supplant this, assuming that we don't have enough experts in every single question right there? So we want to ask whether or not it will be useful for an LLM to supplant the need for an expert. We have a lot of data, particularly how to use packages in the form of vignettes, manuals, and we explore two options: a cloud-based deployment on Azure OpenAI and on-premise deployment of open source models using Ollama. Here at HMS, we have a research cluster running a couple A100s for some of these models right there. Some background: there are commercial solutions. Many of these use REST APIs, much like we use for the cloud containers. They're very good on performance and UI, and also have some backup services that we can but there's of course a cost. There's also transparency on what the model's actually doing and control of that. We also been looking into open source or open weight solutions in the case of Llama 2. So far, we've isolated Llama 2 seems to be the largest candidate right there, simply for having reached some of the performance of closed LLMs, or 3.5 at least. But also it seems to be the largest one. And Llama 3, which is now obsoleted by 3.1, is out. It's getting very close to the closed source models right there. And we had to develop the cluster solution for our HPC, which I will gloss over for this matter, to give you the results of this project, which was one of the surprising findings we found was that base training data matters, and GPT-4 has already been trained on largely Bioconductor corpus. So without any augmentation or grounding, we're able to get pretty ideal answers from it. So an example right there, we used examples from support sites, and we were able to get pretty ideal answers and prompts from it. We had to spot check a lot of them for correctness. This one actually did give a good reference for the libraries that it uses. Llama 3, however, does need additional context for it. It was not trained on Bioconductor. We don't know particularly what's in these sets right there, so this was an interesting discovery for us. So we have a real answer. It gives a function that doesn't exist in this package right there. It's good R code. It's just not what we need right there. Grounding this with a RAG, we've used BioC vignettes as a context reference. We were able to get a much more grounded answers. So a lot of the LLMs have to rely on some, if we don't have it in the base training data, they're going to have to provide additional context to that. And we were able to use just storage of a lot of vignettes that we scraped, and we were able to get that, and also get the actual package links, because these links are in the vignettes. We can actually get references to stuff in the Bioconductor stuff right there. We also explored a few deployment options, some locally at like Open Web UI, BioChatter, which is also a Bioconductor package right there, Chatter. We also may be looking at support site integration, having that as utility. That will require some web front-end infrastructure that may have been created, or we can just get off the shelf. There's also a chance that if there's a platform migration from self-hosting to something like Discourse, there's a chance that they also have LLM integration to that site as well. We also, and for the next 5 minutes, we look into evaluation strategies, how correct these responses are. So we have 3 evaluation strategies: using ground truth embedding distance, using diffusion, and also having the LLM evaluate the responses of an LLM. So an embedding-based evaluation very quickly is simply using another transformer, an embedding transformer, to generate text embeddings of the answers, and then calculate the textual similarity. So you have a high dimension of space of these embeddings right there. Ideally, the values for those embeddings would be very close to one another if the answers are very similar. So we took a data set that was basically a bunch of BioC Q&A stuff, 10 questions, embedded ground truth with a sentence embedding model, compute the cosines for similarity, and give a plot right there. I have a link for the whole presentation that Andrew Ghazi provided for this. And some very interesting insights on that, mostly that the cosine similarity between ground truth models actually seems to be dependent mostly on length rather than content. We found out that some of our negative controls actually were naturally shared across most models, GPT-4 and Llama. So this might actually not be a very good evaluation for this, but we do have some ideas on how to improve this analysis. But I'm just giving the results here. A diffusion-based analysis, we also look into this, just get a small ground truth, diffuse it, make the example very slightly so that way it breaks, and then provide the model with a diffuse and see whether it can restore the actual correct code answer right there. So the experiment, we set 10 coding errors and anti-patterns, bad practices, just using one line code to change that right there. Model is given diffuse error as a prompt, and we did zero shot. So we did see very low inability to change some of this. This could be a very good test of reasoning right there for a lot of these answers right there and trying to spot for errors. But surprisingly, the closed source models outperform Llama 2 and Llama 3. I have not checked this on the latest Llama. My guess is that a high parameter model, these are the 7 billion parameter model versus the GPT-4, which is unknown, maybe trillions of parameters, who knows. But a high parameter model may provide better reasoning. We still haven't tested that yet. And then we wanted to try this example right there, have an LLM evaluate the model responses as a judge right there and correctly give it a yes or no answer and see what we're going through. This test would have been ongoing. We may be able to find better test sets and stuff. I'm happy to put it out to the community and see if they have better ideas for doing this experiment right there. Right now, we're a little blocked on getting the GPT-4 models back up. So I don't have results today right there. So we have questions for this, as far as LLMs are going to be part of the cloud working group because a lot of this is done on remote systems, particularly if you have a GPU. You can have a GPU on your laptop or you can have it running on a CPU right there, but for generalized, very good rapid responses, it's going to be somewhere else. It's going to be in the cloud somewhere. So we want to look for a level of investment, interest in that from the community, maybe involvement of CWG and community developments, maybe with GPUs on Jetstream or somewhere else, and also support from the Copilot team and just general questions on the support side right there. We have an older site database that we could use for training right there, but all we do have a lot of. We did hear complaints about privacy complaining for this database right there, which we are interested in discussing. There's also more questions on migration to other platforms, which does train on your data anyways. And as seen before, GPT-4 already has that part of the training data. It's already out there. It's on the web. It's going to be a bit of a fluff to ask about things that has already been scraped. So that's where we are at.
Thank you, Alex. So as I mentioned earlier, our next I have the same slides. The next meeting of our cloud working group is August 15th, 9 a.m. PST, noon Eastern time. And our Slack channel is Cloud Working Group. Please join. We have a great groups, not too much people, but we have active group members. So I hope next year we will show the real the outcomes of our projects. And one more maybe thing is, as as Tyron mentioned, AI and cloud. So it's like a pair. We are a cloud working group, but we are working on the AI solutions too. So I hope one day we will have the AI working group too, but probably the same people will work on the same topics, but probably you will ask for the AI working group soon, but we are working on these topics too. So thanks for your time, and I think we can have your questions now.
Any questions, or including the direct questions for that Tyrone asked, or anything about the cloud working group? Thank you. Yes, will you please go to the microphone? Thank you.
You had mentioned we have, I think it was a 5 terabyte a month per limit for the checking of things. Where are we at roughly? Like, when do you estimate we'll have to start worrying about that 5 terabyte jump?
For now, the 5 terabyte is the monthly limit, and it's enough for now because the data size is less than 5 terabyte. The only solution is increase the limit, and probably we will do that. But for now, we don't need it because the size is small. But if we exceeded the limit, there's no scan. But for now, this is not the case because the data size is smaller than the 5 terabyte. Is that the answer of your question? Yeah.
Is that scanning done every time a resource is requested from the?
No, whenever the new file uploaded to the Bioconductor Hubs, yes. Yeah. It's not scanning the files while downloading. It's just once we edit new file.
I guess if we have a little time to discuss GitHub Actions, I guess I did raise the question when we were at the TAB meeting as to how many developers are desirous of guidance on GitHub Actions. And I guess the response was not super positive. So it sounds like we have to do more training in terms of how the developer experience could be affected by understanding what GitHub Actions can do. Do we know even how many Bioconductor packages have a .github folder? I guess we could find that out with code, unless they've been blocked somehow with an ignore. Do we know anything about how many developers are using GitHub Actions?
Alex, do you know specific number? Nope.
No. So maybe probably we need to, I think this group is an appropriate one to do some training and evangelism about how development can change. But the project itself is a little ambivalent about how these, GitHub Action workflows fit into a general, Bioconductor package. I don't think we've given any guidance on how people should or should not do that.
Definitely, they should do that from my perspective. But yeah, maybe we should discuss about the trainings.
Yeah, I think we could definitely do some training, especially we have there was the developer forum. I'm not sure how active it is, but I think that's the best way to sort of get everybody in the community on board. I think then the response will be more positive.
I think we have a question. Yeah.
I have a question, maybe more to Alex, about this workshop environment that we had for this workshop. So is it possible to set it up as a dedicated, on my own premises? Or is it some...
Theoretically, yes. So all the software stack that's used is open source. What I'm currently using is a slightly modified version of Galaxy, but I did PR all the changes upstream. So if you take the latest dev version of Galaxy, all the changes should be in there. It does take some work. If you have a Kubernetes cluster, that is relatively easy after that, because it can, like, all the stack can come as configuration. So I can give you like a very similar configuration to what the workshop instance, and you would just be able to deploy it on the Kubernetes cluster. If you just have like an HPC cluster or something, like more just a fixed machine, that might be a little harder. It is possible, but you would need more help from the Galaxy team as well to get help with the Docker runner, because I only use the Kubernetes runner in Galaxy. So I hope that helps. It is all just running the Galaxy project / Galaxy software. So if you go github.com, Galaxy project Galaxy, that's like ultimately the base of what is running. But it is a modified deployment to run on Kubernetes and use the Kubernetes runner. Definitely Slack me on the community Slack, or email me, and happy to help. But yeah, it is possible, but takes some work, I guess, is the short answer.
Okay, thank you.
So just going back to the GitHub action question that Vin said, I think from my perspective, there's no unified approach yet that has been developed. But I just wanted to give my 2 cents on that. I think if once we have that ready, it could be valuable to add it to the developer guide book thingy as an actual sort of pre-requirement prior to submission to the GitHub repository for submissions. So that you can say, well, as long as it's not all green, then there's no point submitting it to developers submission repository. Thank you.
Any question? Online question? No. Okay, just maybe final question. How many of us using the cloud resources like virtual machines, HPCs? Cool. Cool. Are you using VMs or HPCs? VM? Virtual machines? Yeah. Cool. So please join our group because we are trying to create the standards for the Bioconductor community. Please join us, share your experiences, and we can add your experiences to our documents. And whenever the new Bioconductor user would like to use cloud, I think they will have a checklist, let's say security checklist, the performance checklist, what type of virtual machines or HPCs that they would like to use or they need to use based on their data sets, based on their the data formats. So we are trying to create the best practices for Bioconductor users. Cool, thank you. And we would like to thanks to the Bioconductor members, and I hope we will have a great outputs in the next conference. Thank you. Thank you, John.
Thank you. Thanks, everyone. I think we have a break until 2:45. So thank you.